All right. Welcome back. Last problems of this activity. It says we have a 7/16 nut driver with a 1.5 inch diameter. Um, there's my 7/16. I actually got the right one. 7/16 inch nut driver with a 1/2 inch diameter handle is used to install a 1/4 inch by 20 UNC bolt into a robotic arm. And so there's some stuff in there that we want to think about. And so the first thing it says, sketch and annotate the screw system. So this, because this one's a little weird, I want to kind of show you what we're kind of sketching out here. Okay, so I'm going to sketch my nut driver. I'm really good at art class. Okay, and then we're going to have our bolt coming out of there. I'll put some threads on it. Okay, so some things that we know is that it's a 1.5 inch diameter handle. That is going to be important. So my diameter here, which is going to be my distance effort, is 1.5 inches. It's used to install a 1/4 by 20 UNC bolt. Now, this number right here is junk. I don't need that 1/4 inch. Doesn't mean anything to me as far as this problem. What it's saying is that it's a 1/4 inch shaft, the diameter. I don't care. This number right here. So when you're working these problems, this is the number that you want to pay attention to, 20. And that is our threads per inch. Okay. So this guy here is my threads per inch, and I want to keep that in mind here as we go through this. They're trying to throw us off with some of this information that we don't need. We didn't really care about that because that's the size of this head is 7/16. That doesn't do anything for me. Remember that screws are all about one rotation. So we're going to use typically circumference and the linear travel up and down. So as I turn this, if I put an effort force in one linear rotation of effort force, how far is this bolt going to turn, in one rotation? How far is it going to slide back and forth is going to be my distance resistance. So it says 27 tells us to find the circumference where the effort is applied. Okay, so once again, circumference is pi times distance. Okay, and we were 1.5 times pi, and so 1.5 times pi gives us 4.71 inches. Okay, so now it says determine the pitch of the screw, and our formula for pitch is P, which is pitch, is 1 over the threads per inch. So we already knew up there what our threads per inch was. So we go 1 over 20. And so we can say that our is 0.05 inches, or threads per inch. Determine the pitch of the screw. Now 29, slide up a little bit, says what is the mechanical advantage gained in the system? So we think about that distance effort, distance resistance. Okay, so going back to this, I'm using one rotation. How far does this go up or down? Depends on if I'm turning clockwise or counterclockwise. So how far this thing moves this way is going to you can think about that being my distance resistance. Well, what is that? That's the 1/20th, right? And then my circumference in one deal is going to be my distance effort. So really, I might make a note here and go, this is my distance effort. This is my distance resistance. Well, what is the ideal mechanical advantage of this guy? Well, remember, IMA is I'm going to kill a deer, DE dr. So distance effort, 4.71 inches over distance resistance, 0.05 inches. And when we do that math, we get 94.2. A really high mechanical advantage. That's the great thing about screws. And we're using, think about if I had a box wrench that I was doing that with instead of, some kind of wrench with a big, on this handle, I was using a big, like a ratchet wrench or something. Man, I could get a really high mechanical advantage. And then it says, lastly, it says, ideally, how much force can ideally be overcome if 5 pounds of force is exerted? Okay. So once again, we are setting that idea of IMA is equal to AMA. Okay. So we can use our formula here to kind of set those things equal how much force resistance if we have an effort force. Okay, so we would say force, let's do this, FR over FE is equal to DE over DR. So how much force can ideally be overcome if 5 pounds of force is exerted? Well, that's saying 5 pounds. And this is my ideal force resistance. So we'll say X. And we're going to say distance effort is that 4.71. And once again, this is that 0.05. And if I plug this into my calculator, say 5 times 4.71 equals divided by 0.05. And I should get 471 pounds. And that is your answer. And that is all of the questions. And I hope that helps.